So hello everyone, welcome to this session on service mesh landscape. Just to kick off, I just wanted to get a feel for the room. How many of you have heard of a service mesh before? Okay, so the hype is alive. How many of you have used a service mesh? Okay, yeah. How many of you can describe to the person sitting next to you what a service mesh is? Yeah, that's about right. So hopefully, by the end of this talk, you'll have a better idea of what a mesh is, the options you have, what you should be looking out for, and how to pick the right one for what you're interested in doing. So my name's Paul Bouwer. I'm a software engineer at Microsoft, and I've spent the last year working with a lot of our customers around the world, looking at service meshes and producing guidance. So a lot of what we're going to see today has come out of that work. So at a high level, the topics we're going to cover off this afternoon are: why do we need a service mesh? What does the service mesh offer? Why should you be interested in it? And when you actually select a service mesh, what are the things that you should be considering? It's a hint, as it's not only the feature set. And then we're going to look a little bit more closely at the three main meshes that are out at the moment. So that's Istio, Linkerd, and Consul. And then we're going to take a very brief look at the broader ecosystem and some of the other things you should be keeping an eye on. So let's start off with why. Why should you be looking at service meshes? Why is there such a lot of hype around service meshes? So to dig into this, I'm going to cover off three broad scenarios. First of all, I'm going to start around security. So typically, not too long ago, and potentially for some of you, this is still what your security looks like. The firewall is the security boundary. All your security is managed by whitelisting IP addresses or by giving access via IP address. And the security is managed at the boundary of your system. So with the advent of microservices and distributed systems, that is no longer what the picture looks like. Typically, this is what your security model looks like. You've got zero trust networks, so nothing on your network is trusted. There's a requirement for strong identity, secure communication between each of your microservices or each of your workloads. Your IP addresses are dynamic. So in the Kubernetes world, your pod may have one IP address today or this minute and a different one the next minute. And all your workloads are dynamic. So there's no longer a way to know the known state of where your things are. And if we look at delivery, previously you would have had a known infrastructure or a static infrastructure. People would be able to name the servers or understand where things were. Potentially your releases were monolithic. There was one release that happened every so often. That again in the microservices and the distributed world has now moved to a picture that looks like this. We've got dynamic workloads and versions. You may have multiple versions of an application running in your cluster or in your compute nodes. There's a requirement for progressive rollouts. You may want to deploy a version at 10%, 20%, test if it's working in production, and then roll it out further. There's A/B testing, canary releases. People want to understand from an observability point of view what's going on in your cluster, what's going on with your workloads. And then there's also a requirement for traffic policy, so being able to dynamically or through configurations set up the policy what workloads should be allowed to talk to what other workloads, and how those should be accessing each other, whether there's rate limiting, whether there's back-off strategies, all that type of thing. And then finally, there's a section around resiliency and observability. So typically, most of you are probably doing this in your code, in your workloads. There are probably an approved set of libraries that you're using. This is doing retries, back-offs, all that type of stuff. So that works well if you're in a monolithic environment or your development environment is a single language and there's an approved library that you can use. We're moving fast to a world where different workloads can be written in different languages, and often the libraries that cater for all of these things are not consistent across those. So workloads are in different languages and frameworks, and there's requirements for consistent observability and policy across all those types of workloads. So we've spoken a little bit about why people think there's a need for service mesh, and I'm probably alluding to the fact that maybe a service mesh will solve some of those things, but what does a service mesh offer that's going to help us with that? So what I'd like to start off with is maybe a definition, looking at what is a service mesh, and this is why I asked you up front. So the first paragraph in this quote by Christian and Bouwer from their book talks around what a service mesh is rather than the value that it's delivering. It's delivering a bunch of capabilities, but that's not really what makes it special. The second sentence is starting to get very much crisper on the message. And you can see there it allows applications to offload capabilities from your application down to the infrastructure. And you can see this crisping of this message is starting to become apparent from quotes from other people. So this is Eric Brewer, VP of Infrastructure at Google. Istio decouples operational aspects of the services from the implementations. Again, we're moving stuff out of our application into the infrastructure level. And again, William from Linkerd from Buoyant. Linkerd moves visibility, reliability, security constraints down to the infrastructure level, out of the application layer. This means that all of those requirements that we saw a little while ago no longer need to be managed within your code. The service mesh can deliver those capabilities for you. So what do those capabilities typically look like? In a typical mesh, you'll have a whole bunch of traffic management capabilities. It all operates at layer 7, which is your application layer within the networking stack. You've got HTTP and gRPC management of traffic. There's dynamic routing, so you can do conditional routing, weighted routing, you can do mirroring of traffic. Resiliency, you can respond to timeouts, you can do retries. Circuit breakers, if there's too many issues per time box, you can actually start failing. And then with the policies, you can do access control to specific workloads. You can also do rate limiting and quotas. So this is maybe you only want, if this service calls this service, it can only call it a maximum 10 times a second. And then some of the meshes also support this testing capability where you can actually use the mesh in QA or dev to actually inject faults into your system, and that tests your resiliency. Then from a security point of view, in terms of capabilities, meshes automatically give you encryption, so you can automatically encrypt all the traffic between your workloads, even if your application doesn't understand what encryption is. This is managed via mutual TLS and certificate exchanges. The strong identity, the talk before me mentioned SPIFFE, and that's an important aspect of a lot of the meshes. So SPIFFE is a specification that gives you strong identity and a way to test that identity, and also gives you certificate bundles, which allows for all the encryption. And then there's also authentication and authorization that the mesh can do transparently for you. And then in observability, typically all these meshes will give you a bunch of stuff around metrics, tracing, and traffic. So a typical architecture is broken into two components, the control plane, and this is where all the configuration and the management happens. You'll have components that you can see there. It's around a management UI or API that controls how the configuration goes in. You've got your rules and your policies. You've got security, which manages the certificates and the identities. And then you've got the metrics, which allows you to collect all that observability. And then typically in the data plane, that's where your compute nodes are. They will either have sidecars so sidecars are patterned in Kubernetes, and this injects a proxy that will hijack all of the traffic in and out of your workload and apply the rules and policies to that. On virtual machines, this may be running as a separate process next to your workload. So I also mentioned way up front that features are not the only consideration that you should be taking into account. There are multiple things that you should be looking at when you decide on a mesh. We've covered some of the technical stuff around traffic management, policy, security, and observability, but there are other things that may be important to you and your organization. So from a business point of view, you may be looking at, does this mesh, is someone offering commercial support around this mesh? Is there a foundation behind it, like the CNCF? What is the OSS license? Is there some sort of governance that allows my voice to be heard in terms of the feature sets? And then from an operational point of view, how difficult is it to install? How difficult is it to maintain? There are a lot of considerations when you add a mesh into your cluster. And then some people may also look at it from a security point of view. They may have compliance considerations around certificates and management of certificates and root CAs. Now, often when people ask me, do I need a mesh, my first response is no. And typically, once you ask some of these questions, they don't need a mesh. I would say once you reach a certain level of maturity and you're confident with running Kubernetes, then start gradually exploring a mesh. If you're in the keynote this morning from Xero, they're not implementing a mesh yet. It's on their roadmap, but they understand that it's a gradual journey. So let's have a look at a little bit more detail for the three meshes. So we'll start off with Istio. So Istio is the one that most people are most familiar with. It's full-featured, customizable, and extensible. So it has a ton of features. You can see some of the project details there. There's commercial support from Aspen Mesh, and then there's also managed offerings in Google and IBM's clouds. So when you look at a mesh, it's often crucial to understand the design goals of that project, and that will guide you around what is important to you and whether that aligns with what is important to the project. So Istio's design goals are around maximizing transparency. This means you install Istio and your workload should just work. You shouldn't have to do too many other things. The one that's super important around Istio is extensibility. You can extend Istio in multiple ways to do things that it wasn't designed to do, or it wasn't it's extending the system pretty much like Kubernetes works. And that comes with some trade-offs. Portability, it should be able to work across VMs and Kubernetes or any other future workload that the project may decide to support. And then policy uniformity talks to if you create policies, those need to be able to be translated in the language across anything that may not actually be Kubernetes. So they need to make sense in virtual machines, serverless Kubernetes. So this is a list of the Istio capabilities. So there's a ton there. I'm not going to go through all of them. Just understand that there are a lot, and this is a full-featured service mesh. You may not always need all of these features, which is also often why we'll suggest to customers to look at what scenarios they want to support and then work from there back to which one of the meshes makes more sense for them at that point in their life cycle. So this is what a typical architecture for Istio looks like. At the top, you've got Pilot and Galley. So Galley is configuration. Pilot is the thing that controls all the configurations and sending them down to the proxies. You can see at the bottom here, there's a virtual machine on the right and Kubernetes on the left and Kubernetes on the right. So what I'm showing here is that Istio can extend its mesh across both Kubernetes clusters and virtual machines. So if that's one of the scenarios that you're interested in, then this is a good option. And then from an operational point of view, you used to use Helm charts to install Istio. They're moving to an operator model with the Istio control binary, client binary, is taking over a lot of that. Istio is super complex to install. There are a lot of moving parts. They're trying to simplify this with profiles and their new schema. This allows you to define a set of profiles that may make sense for your environment or for demos. As I said, there's complex configuration. Probably a year ago, Istio used to get a bad rap for the overhead it introduced with running each of those proxies and some of their components. They're doing a lot of hard work in terms of bringing down those numbers. So keep an eye on some of the benchmarks out there, and then you can gauge for yourself whether some of those overheads are fine for you. So if you're looking at Istio, typically, if you have these type of scenarios, then Istio is probably a good fit for you. If you require a number of those capabilities that are listed, it's good for you. If you require routing and access controls based on auth or JWT or claims, Istio is a really good option. Also, if your service mesh, if you want to extend it across Kubernetes clusters and virtual machines, this is also a very good option. And then they also support multi-cluster out the box, so you can actually span the mesh across multiple clusters. So Linkerd is the next one we're going to look at. So this is an easy-to-use and lightweight service mesh. You can see there it's under the CNCF, and commercial support is through Buoyant, which is the creators of Linkerd. So Linkerd that we're talking about now is actually Linkerd 2. It was a complete rewrite. Linkerd 1 was based on Java, so it was a little bit heavy. So the design goals of Linkerd, and this is crucial to understand, is keep it simple, minimize resource requirements, and just work. So if you've tried Istio and Linkerd next to each other, you'll actually understand these design principles. But it also comes with some trade-offs. So their capability list is not as extensive because they're focusing on simplicity and reducing the latency within the pipeline. And if you have a look at their architecture, you'll see that. So it's really simple. There's no central components that everything has to go through, so the bottlenecks are removed. And it, at the moment, only works on Kubernetes. So they're not focusing on virtual machines or anything. From an operational point of view, it's a very nice user experience. It does pre- and post checks. When you install, everything's done through the CLI, and it comes built in with web dashboards. With Istio, you typically have to install additional web UIs to get the insights. So just a heads up here, as I mentioned, it's a smaller set of features that Linkerd will implement. Some of the features are not built in, and the philosophical opinions point at the end there was because of their design principles, they typically will not put things into mesh features that Kubernetes can provide natively. So it's just trying to understand how you would do this versus in Istio or one of the other meshes. So it's just something to consider. The scenarios that you should look out for if you want to use Linkerd, if you have a simple use case, if all you're interested in is mutual TLS between your workloads, then I would start with Linkerd because it will get you up off the ground quickly. You'll understand how to leverage a mesh. As your capabilities change, if Linkerd doesn't support them, maybe move to Istio then. So if you have super low latency and low overhead requirements, then this is definitely the mesh for you too. And finally, let's look at Consul. So Consul from HashiCorp comes from a non-service mesh background. It has been around for a while. They've added capabilities to it now where it can behave like a service mesh. So there's commercial support through HashiCorp. Their design goals, API-driven, running, connect anywhere, extend and integrate. So they want to also be able to run across any workload you want, whether that's VMs or Kubernetes. So this is also a core design goal for them. This capability list looks pretty much like Istio. They do a lot of things. They also do multi-data center or multi-cluster or multi-VM gateways. They can span across VMs. There's a ton of stuff. And also around security, because they have HashiCorp Vault, you can have a little bit more control over your certificates and your identities. This picture is a little bit more complicated than the other two. They run an extra component in the control plane, so it's the client, and that talks to the quorum of console servers at the top there. But once you pass that, everything on the bottom looks very, very similar to the others. And again, you've got Kubernetes and VM, so it can span those types of workloads. To install this, it's a Helm chart. It's pretty stock standard. This one also has a ton of configuration options, so it can be a little bit complex to understand each of those. You also need to understand some of the console concepts. So if you're not familiar with console, you'll also need to upskill on understanding some of the core console concepts before a lot of this will make sense. It doesn't have tracing support, and unlike the other two, it doesn't use Kubernetes DNS. It runs its own concept of services, which is, again, something you'll need to become familiar with. The bottom bullet point there is also something that can take a bit of getting used to. With the other meshes, you can refer to workloads with their Kubernetes DNS entries, whereas with console, you need to set up indirections. So your workloads will be talking to localhost, and the proxy that console injects will then do a mapping to the actual console service, which could be a Kubernetes DNS entry or a virtual machine DNS. So the scenarios that this is useful for, extending existing console connected environments. So if you're using console already or other HashiCorp products, this is very good. And then if you have requirements around certificate or compliance, this is also a good option to have a look at. And then it can do multi-cluster and service mesh expansion across VMs and clusters. So these are the three we covered, but in this space, nothing stands still. So Kuma is a service mesh from Kong, the API gateway management, and Mesh is a service mesh from Trafic. So both of these are super interesting. They're starting to bring interesting concepts. Kuma can actually run its control plane inside or outside of Kubernetes. And Mesh has taken a slightly different approach where they have a proxy on each node rather than a sidecar. That also has pros and cons to it. So within this space, because of all those meshes, there's also an effort to do some standardization. So there's a project called Service Mesh Interface. And this is looking at a standard way to describe some of the basic interfaces that each of these service meshes will be providing. So there's a bunch of companies that have contributed to this, and these are the four areas that they're looking into at the moment. So vendors are very interested in this because it allows them to build components that if they build to an interface, they can actually then work on each of the meshes. And then I think as time progresses, as users or end users or operators, this may make a lot of sense to actually leverage. So those are the meshes. There's also a broader ecosystem within the service mesh landscape. So if you're doing Canary releases, Flagger from Weaveworks is definitely something you should look at. They're actually using SMI, and that has allowed them to support multiple meshes now. So Flagger will actually allow you to do Canary releases and multiple rollouts and progressive rollouts. Solo has a service mesh hub. This is also really interesting if you want to start playing with these different meshes. You install this in your cluster, and it will allow you to install each of those meshes really easily and get to play with them. Meshery has also got a playground which allows you to install the meshes quite simply. Something interesting they're doing is benchmarking. So they've started a community effort to start gathering metrics around what the impact of each of these meshes is. And some takeaways, this is a very active space. Make sure you understand your requirements before selecting a mesh. Focus on the scenario you're trying to implement rather than the feature list from each of the meshes. Once you pick a mesh, understand the implications of deploying that mesh to your cluster. There's overheads and there's operational overheads. And then keep an eye on all the standardization efforts and the broader ecosystem. Thanks.